So the question is, draw what is meant by a two-compartment model in pharmacokinetics and use propofol as an example for explanation. So basically what you do is you define a two-compartment model, and then so use of two-compartment model to model the distribution of a high lipophilic drug to propofol without a high volume of distribution. So two models explain the biphasic propofol distribution, and we know that. So V1 is actually central plasma vessel rich group, which is brain and kidney and renal. And V2 is poorly perfused, such as fat. I wonder if that's also muscle. Let me check. Okay, it doesn't say, but anyway, it says heart. And then the second one is fat. And so drug enters the V1, distributes to V2, and redistributes to the central compartment. Drug elimination from central compartment K10, removal from V1 by elimination from the central compartment, which is K10, and distribution to the central compartment K12. Distribution from central compartment to peripheral compartment. So that's easy enough. And then you give the equation. And the fact that it's biphasic. So biphasic alpha phase and distribute. So biphasic. So that describes the concentration over time after the initial bolus in a two-compartment model. Alpha phase is this distribution phase, which is T half alpha, ln 2 over alpha, and we know that. And then this phase ends when V2 is greater than V1. Beta phase is the elimination phase. The drug from V1. Elimination of V1 and redistribution V2 back to V1, which slows the fall V1. T half B elimination half-life. And this models the lag between CP and E. Model explains context-sensitive half-time because an increased duration of infusion increases context-sensitive half-life due to distribution to peripheral, and increased accumulation, large amounts to be redistributed. Then you can draw a graph which shows ln A, ln B, and it's a two-compartment. Assumptions, two-compartment only. The body is basically two-compartment only. The drug is only eliminated by K10. It's first-order kinetic, purely mathematical, and based on data of healthy patients. Note, due to propofol high lipid soluble distribution to tissue is best explained by a three-compartment model, with more models not pharmacokinetically beneficial. So that's my answer. I would just add that a three-compartment model, this is from ACE's answer, refers to T half alpha being a rapid distribution, and then T half beta being the slow distribution, and T half gamma being elimination. Which is more accurate. And then I will also talk more about propofol, particularly when you're referring to these. So you'd say propofol. And let's see, there would be a good answer if you just talk about propofol.